Welcome everybody to today's Accendo Reliability webinar. This is Fred Schenkelberg. And I wasn't really sure about the title of this, but we'll dive into it. And what I want to do is talk about basically a progression that I've witnessed in a good number of people. And unfortunately, though, I think a number of people have stalled. And sometimes they are good with where they are, and that's fine. And others are not sure how to move forward. So I thought this might be a way to look at kind of a progression for being a reliability engineer, and a couple of thoughts of how to move forward with your career and the impact that you have with what we do. So there's tons of stuff to talk about here. So let's dive into it. All right. Hopefully I spelled reliability right. I have it in my spell checker so many different ways. One of the things many of you have heard me say is that reliability occurs at the point of decision, or it happens in design. It's inherent in a product, whether or not anybody in the development team or production team even consider it. The ending product will have this characteristic that we call reliability, meaning that it will have some distribution of time to failure, given the various ways that our products are used and environments that they work in. It occurs whether or not anybody even pays attention to it. And in part, it's the collective set of decisions that are made in the design that create the inherent reliability that's built into a design and built into a product. Now, part of what we do as reliability engineers is bring attention to, or influence, or assist the decision making that goes into creating and building products. It's those kinds of things that occur. Do we use vendor A or vendor B, for example, that in the long run make a difference on the performance aspect that we call reliability of a particular product. So a good place to think about what we do as reliability engineers is bring attention to, or focus to, or information to support the creation of a product that meets our particular reliability goals or our customers' expectations, or preferably both. So that's what we do. Yet there's no one way to go about doing that. And there's actually, when you're first getting started versus when you're been doing it for a while and have great impact, there's different things we do. So that's what I want to talk about in particular today. Now, there's such a thing, as you get off your education, or you get tapped on the shoulder and somebody says, you are now the reliability engineer, or you get hired as a reliability professional, or you don't even have that title, but you're interested in improving the reliability, the processes that go into creating a reliable product. And you may be learning different tools and techniques, and you may be applying them, and you may start to have a real good impact. At that point, I think you're a good reliability engineer. You can help a product make its way through the process. You can help your team to achieve those objectives, and that's all great. That is a very valuable aspect of what we do. And plenty of people are good reliability engineers, and there's nothing wrong with that whatsoever. Now, a few of us, not all, have this aspiration to become a great reliability engineer. And I'm going to separate that just slightly as to, and define what that is. But before I do that, let me ask you, let me get into the Q&A tab here, or into the chat window. And what do you think separates good from great? Good, you get the job done, you influence a team, you get a design out that meets goals, you get a product that's consistent and meets reliability expectations. But what would be a great what would separate good from great? What do you think about that? So instead of going through the whole presentation, a couple of you may know this already and or have some great ideas that would make that difference. So I'm very curious. All right, Kim, good one. Yeah, achieve consistent world-class metrics. It's a really trick there, Kim, is you have to pick the right metrics to be really good at. And if you make them easy metrics, that I don't think that quite goes. So but it's an idea. It's now, Julie, I don't know about exceeding expectations. Last night I heard a whole long story on the news about quiet quitting. I think there's meet or exceed the expectations, but it's from the customer's point of view. So I'm going to read into your fragment there and put it that way. Constant reliability mindset. Yeah, I like that one, Mahindra. That's good. You know, it's kind of that continuous improvement idea. Yep. Create industry standards. For example, something to replace MTBF. Let's do that. That would be world-class. Constant assessment of process and reintegration of data and completed projects to improve the process. Yeah, I like that. Good. Takes the broad view, doesn't just consider time to failure distributions, but also looks availability management. Yeah, Michael, I agree. Is expand your scope and is a part of that. But we'll probably touch on a good number of these, maybe not all of them. Yeah, influences the design. Now, I think as even a beginner, just starting out, or even as a good reliability that's what we do. We influence the design. Now, if we expand it into the other attributes of quality, I agree that it's moving into the great category, is that we're having a broader scope or span of influence. But it could go lots of different ways. So let's dive into this a little bit more. Thanks. All right, so getting started, you get out of school or somebody says, hey, you're now the reliability professional. And so here's a question for you, staying with the chat window. What's the difference between education, which I'm going to say is like university or conferences or you know, seminars, workshops, all that kind of stuff, versus learning? What do you think that difference is? And I'm going to preface this by saying I've known perfectly brilliant PhDs that were in, I think this one particular person was in material science, but had a great study of reliability engineering, yet had never been in a factory. So they had a great education, but they had no experience. Yeah, field experience. Perfect, Simon. Yeah, you're all exactly right on it. And so part of learning is learning what are those things I learned about in school that are practical or useful or are enough to solve the problem but won't cost too much. What are the ones that are going to add value? And then the other idea here is that you start to learn that, you know, in school we can, we'll make that assumption, and it simplifies the problem, or it allows us to model it, or it allows us to do an extrapolation, or it does all these crazy good things. But we typically don't have a lab full of actual products. We don't typically do all these exercises in the classroom with a factory downstairs. Now, some programs do, and you get great lab experience, but it's just too easy to learn that we just make assumptions and then everything's okay. Now, you've learned early on, especially if you have a good person that's working with you, this allows you to make the assumption and then realize that that was a mistake, or they insist that you check the assumptions, even down to the measurement system analysis. Is your gauge, is what you're using to make the measurements any good for what you're trying to do? So I think we start to learn as we roll into becoming a reliability engineer. And it's not only what's the difference between accelerated life testing and highly accelerated life testing, and what are they for, but we also learn all the nuances of all the different kinds of accelerated testing and all of the different trade-offs and pieces and parts that go to it. I think part of our learning process really never ever stops, right? And it comes with practice, it comes with failures and learning from those failures. It's from our products failures and learning from those product failures. Um, a great way to learn about root cause analysis is to have a problem that says, hey, it's not working, now what do we do? And figuring out the basic process of doing a root cause analysis and solving it. Many organizations have bits and pieces of all of these processes in place already, even if you're the only reliability engineer or first one there. And while they may appreciate your brilliance of putting Weibull plots together, that's not the only thing we need to have happen. We also need to do root cause analysis and design for reliability activities and getting stable, consistent production processes, working with vendors and so on. Our scope on day one is usually pretty large, or it can be. And so part of what we're trying to do is, as we get started is, well, what bits and pieces of what I already know works here? And vice versa, is if you don't have a formal education or reliability, what do I need to know to get up to speed? So typically this takes a little while, not too long for most people to get up to speed and actually start making a difference in their organization. Oops, let me get over to the right screen here. There we go. But we're engineers by and large, right? We're there to solve problems. We're there to figure out what could go wrong and what do we need to do to prevent it, which is adding a lot of value. Or if there is a problem, then what do we do to resolve it and to avoid it from happening in the future? But we quickly learn the difference between the scientific method, which many of us grew up through all of our science classes through school, and just the basis for how we do go about becoming engineers, and the difference of all these other processes that are much more practical in an industry setting, right? While it would be fascinating to do a great big PhD thesis level research on how electromigration occurs, in practice, that's already been done. We have papers and papers on it. There's even videos that show the migration of copper along a small trace. I saw years and years ago. It's been done. Let's build on top of that and use that knowledge to avoid it from occurring in our product. Or let's look at continuous improvement process. They don't have to be massive, big, huge industry shifting types of things, but they allow us to make systemic improvements over time that incrementally add up to be pretty broad. So if an organization doesn't know about stress strength calculation or derating and they don't use it in their design considerations, doing a quick lunch and learn kind of thing, or a couple of discussions with your key engineers to say, let's apply that. Here's the benefit. Here's the basics of how to go about doing it. Let's make it happen. And then checking that it is making a difference, and then showing the rest of the organization that it was actually useful, and reinforcing this process of, yeah, let's do derating. It actually helps. Let's do those kinds of things. So part of what we do right from the start is start to identify problems or areas of concern. We learn enough, we get up to speed, we talk to enough people to work out how to avoid problems from occurring, or vice versa, is things do go wrong, things do occur with prototypes and early production. Well, let's figure out how to solve it. And I think that's part of why I got so interested in reliability engineering early on, is seemed like every Friday afternoon, but there's this never ending set of constraints that allow us to make products that allow us to have bump into the edges where it doesn't quite work. And figuring out where those boundaries are is, I think, a lot of fun. But by and large, we very quickly start adding value, right? Now, adding value, many of you have heard me talk about it before, is making a difference. It's not just cutting the failure rate in half, but it's in many of you were talking about earlier with is going above expectations, or contributing a lot and so on. Now I could go do parts count predictions all day long and produce hundreds of them for every product that we have in our portfolio, but that's really not all that useful, right? Let's do something that actually makes a difference, that influences those decisions that make a difference in the product. So it might be the rating process, or it might be understanding a failure mechanism. Um, Hopefully you never have the situation where a young engineer says, hey, let's make a circuit board with silver on it instead of copper. It's so much better conductor. And for our application, we need blah, blah, blah. And they'll come up with all kinds of great reasons why using silver instead of copper is the way to go. Well, a little bit of experience can tell you that silver is called the mobile ion, and it will create new traces all over your board if you put silver down on it. And so it's usually, unless it's bound, it's got to be chemically bound. Otherwise, it will move. It will go to wherever the voltage takes it. And that means cross traces. And so adding value by just doing something that doesn't matter, but versus saying, let's think about this. This is a new material. It's not used a whole lot. And I remember having that circumstance and going, why is that? And I went and asked a few people and learned very quickly that silver is not used because it has this peculiar ability to move and leave the trace that you printed and go wherever it wants to go, pretty much. And then that way, Ken, on top of that, then there's tin whiskers, which is a whole nother phenomenon. But I think early on, as we're getting started, part of our value is recognizing that we're not there just to say, no, this isn't going to work. It's, have you considered, or let's look at it this way, or here's some quick research I did about using plated tin and then bending it. That increases the odds of having tin whiskers. And there's, we're still learning a lot about it, but let's take some best practices here and avoid that from occurring. Now, I found early on that being able to work with the rest of the team so that they had the information to improve the decisions they made to make a better product was a lot of fun. And so part of getting started and building a career in it really is independent of whatever discipline you're working in, is if you enjoy what you're doing, you'll probably stay with it. If you get the opportunity or you have that desire to dive deeper into these things. Now, the bottom line though is that as we start working with another group, we're going to make a difference. Be asking the right questions, running a test and giving them meaningful results, sorting out a Weibull plot of field data that shows that, vendor A is really better than vendor B. Those really do make a difference in the organization. And so my suggestion is to start quantifying that difference you make. And we have other webinars and other ways of helping you figure that out, but quantify it. So if choosing vendor A versus vendor B would make a 2% field failure rate difference, well, what's that 2% worth? What's the cost per failure? And sort that out, add it up and write it down and make sure, one, your boss knows what it is, but it's a way to build credibility in this reliability stuff that we do. And I found over and over and over again that the value of what we do is pretty magnificent. It's probably the right word for it. It can make a huge difference in an organization. Contrary-wise, if we make mistakes and or the team ignores our advice, it can be pretty catastrophic too. Let's focus on the positive side though. And I know that many of us actually make a difference. So quantify it. And so that's a way to get started is learn the ropes, learn the tools, learn the tricks of, of how to pick and apply what you're doing, but then also recognize that it does make a difference and quantify it. So I think this isn't really a question. This is more of a being told what to do versus deciding what to do is really more about transitioning from a brand new hire or just assigned to a job saying, hey, can you go solve this? Or we need this analysis done, or can you run these tests? Is being told what to do. But then at some point, we're going to say, you know, this would be more valuable if we did this HALT test instead of ALT, or if we did a Weibull analysis of our field data versus building all new products and figuring out all new systems and new supply chain. Let's see if it's worth doing. Are we close enough? Can we solve our current problems by understanding them better, for example? I think that's the point when you transition into a good reliability engineer, is where it changes from you're doing a set of tasks because somebody requested it, to starting to recommend tasks that would be more valuable, that would be more useful. And so this is really a transition slide instead of my typical question slide. So being competent, which is the next step, and where many people I've met over my years work. That's what they do, and you need to be competent to start. You know, you get going, you get up to speed, which takes some amount of time depending on your circumstance and interest in you know, studying and learning. But it's basically that you know what's out there. You know that there's a range of different tools available. There's all these different phenomena and techniques and processes within reliability engineering, but also within the quality group, within the engineering groups. You know about product life cycles. You know about the PDCA. Thanks for somebody answering, or James for answering that, or Sean answering that question for James. I saw that. There's all these different tools and processes, and some organizations have different sets of training or experience, and they use different things. There may even be the same name. I don't know how many different names there are for overstress testing. Multiple overstress testing, or I don't remember what most stands for. HALT, Strife we used at HP, which was similar to HALT. Step stress testing is another variation, but they all are variations of naming with slight different nuances to essentially the same thing. Let's test this till we get failures. But what I think means being competent is, instead of being asked to go conduct a HALT test, is knowing why we're doing a HALT test and why does it make a difference? What are we trying to achieve? And will those results actually be used? It makes really little sense whatsoever to me to be told to go do a HALT test. You do the HALT test and they ignore the results because, well, you overstressed it. Well, of course I overstressed it. Right. And so the basic idea is that in being competent, you know where this tool or method or technique fits in to the larger picture. What is it supposed to do? What kind of result should we expect? Now, a simple example is let's say we're doing a comparison, a simple hypothesis test. If we only have one sample from each group, well, running a statistical sample analysis of that is kind of fruitless. We just have two pieces of information, two individual values. And there's not a lot we can do with that. And the ability for us to say this one's clearly better than the other one is muted because we just don't know what the spread is, what the variances are. Well, let's say we get enough samples. Is it answering the question sufficient for what that decision maker needs to know, right? If they're very risk intolerant and it's a great big major decision they're making, they may want a lot more samples to be much cleaner at separating out these two groups of, say, two vendors' products. Which one is clearly better under these sets of stresses? That may make a difference. So being competent allows us to go through what is the nuances of the request or of the decision that is being made. So what is the right information that we need to provide so the decision makers or our team can make the right decisions, right? Now, it also includes and I think many of us have run into this, is like, well, of course it broke, you overstressed it. And being able to explain in a coherent, clear way why we did that, why that's useful, why that result that we got, this failure mechanism that was identified, was actually good information and that we need to focus on it. And so it's a little bit of both of that, right? But having the ability in being competent is saying, here's the right tool to use at this point. And that includes having known about what the options are, but also knowing what the constraints are and the requirements are for the people that need that information. So I see Carl's got a few questions here. Let me take a look at that. Focus on a particular problem at hand. There is something to that. The unfortunate part is that if you've ever seen a fracas system or a Kappa program or anything like that, is the span for many of the issues that we work on, say existing field problems or prototype problems, while some of them are pretty easy to identify, understand and solve short and long term, some may take months, if not years. And so by just using that one example, is by its very nature, we often have a lot of different issues that we're dealing with and juggling. There's been a couple of times when my primary job allowed me to focus tremendously on, say, accelerated testing. And so I got to be really good at accelerated testing for the products we were working on, and did all the due diligence, checked all the assumptions. I learned a lot, and also added pretty useful information, at least I think so in hindsight, to the rest of the team. And the idea of having that luxury, I think, is a privilege that we all don't get. But being good at one area is actually part of being competent, and I'll take that to heart. But focusing on one thing versus to the exclusion of others, I think that's a forever dancing problem, because priorities change, constraints change, priority or magnitude of the problems that we're working on versus not working on are changing. But there is a great value to keep focusing on one thing and actually getting it solved well. There's certainly a part of that. Yeah. Yeah. Solving problems is, yeah, you do need to focus, but there's also, you need to have a team, which is, the 8D, 8 disciplines type approach is like step one is preserve the data, preserve the information, and two is build a team, if I remember right. But oftentimes our ability to focus, to do the research, to understand something, and not be distracted to a fault to where we're not getting anything done. I think there's a balance there, and every one of us has to find that particular type of balance. Yeah. All right. Let's see what now, this is kind of related to what you were talking about, Carl, in those questions, I think, is that it pays to be familiar with the existing product lifecycle that an organization has and the milestones and the criteria that they provide there, being familiar with existing guidelines and internal design information, being familiar with what the team is using for a failure tracking system. And in some cases, you might end up being the expert at those particular areas. Oftentimes, reliability folks will bring in expertise around failure mechanisms, or around testing, or around failure analysis, or around accelerated testing, or statistics. Many of us get labeled as statisticians pretty early on because of the amount of statistics that we typically use and are expected to use. Now, there's a trade-off, right? How do you pick what you want to be good at? Or does it just come to you? Is something that you get asked a question, or you're handed a project and there's this interesting part that you go, I'm going to study some more on this. And what I've learned is that And what I've seen with other folks is that it's surprisingly easy to become recognized as an expert. It takes about 2 weeks more focus of study and understanding, a bit more depth of understanding, a bit more interviews you've done with people that know that particular phenomena that you're working on, to be ahead of everybody else. And then you get recognized as the expert on whatever. And then, well, that's great. And then more people ask you questions about, hey, can you help me with this statistics problem? And then you learn a little bit more. You now are the go-to person eventually for all these kinds of similar type of questions or problems. And that's all good. It may occur because you want to be the statistician in the group, or it may occur because you're really good at conducting HALT and finding crazy good information. Or it may occur because that just happens to be what you're doing and getting requests to do and recognizing are things that you should be doing. Getting really, really good at something is great. But what I found is that if you only do one tool, if you only do FMEA, if you only do HALT, I think you're missing out on the ability to say, what's the right tool? What's the right exercise? What's the right method that we should be using? Excuse me for a second. I was worried about the construction next door, and it's my own throat. Sorry about that. What I recommend and what I've seen as being, what I think of as being competent, is being familiar with accelerated life testing and statistics and fracas systems, the failure analysis systems, and continuous improvement programs, and in the variety of different systems and tools and methods that are available to us in our toolbox. You might be really good at a couple of those and be focused on those, but I don't think that means that being exclusion, that the only thing I'm good at is this, so therefore the only thing I do is this. I think that misses the boat. Creating a product is never the same from one cycle to the next, for one organization to the next. We use similar tools and techniques, yet every set of constraints is different. Therefore, our contribution to the reliability program is different. And I think that's what competent means, is that you are able to match the advice, the insights, the recommendations, the activities that we do to fit that particular circumstance. And that requires that you're familiar with a broad range of different things, that you are familiar with and able to use or conduct a HALT test or an accelerated life test. What is the problem you're trying to solve, or what information are you trying to create? But it's that old adage, if the only thing you have is a hammer, everything looks like a nail. So part of this is making it clear that the expertise is a balance between those things that you enjoy doing and are good at, and others recognize you as being the go-to person for. That's great. That's a perfectly good thing to do. And there may be more than one area that you're really good at. Yet I think competent is then also being familiar with the rest of the tool set and able to recognize when you use tool A versus tool B. And I think that's a big part of what we do. Let's see, Brent saying every technology company makes unique products. Yeah, they're unique. They're almost always the same. How many cell phones have you seen that basically use the same components? It's amazing. I have changed jobs often, learning that new products and technology become an extremely important skill. Yeah, no, I agree. No, there's extraordinarily clever people out there in software, hardware, and electronics that will combine the material sets that we're all using in unique and interesting and sometimes dangerous ways. There's no doubt about it. I think the edge of what we work on and recognizing what's new or different is one of those common things that we get drawn to, because there's stuff to learn there. There's stuff that we need to know, is will this work or not work? Yet when you look at the difference between the various phones that are on the market, they're remarkably similar. The same with automobiles. You know, the big innovation of putting a bigger battery in a car and using an electric motor, I think has been around since the early 1900s. And it's just another way to create torque and turn wheels. Well, an amazing amount of stuff we have is similar across industries. And some of it is because engineers are dealing with a similar set of constraints and a similar set of material sets and similar knowledge and background, and we're solving problems. Now, the individual solutions may be subtly different, and some may work better than others. That's where the edge part comes in and where we get involved quite often. And every now and then we get this amazingly breakthrough phenomena that occurs, and that's fascinating. I think back to the early days of inkjet printing. It was pretty much magic when they invented it and going, hey, this works. If we heat it really fast, it'll blow through this little hole here and we can kind of steer where it goes. And it went from this crude concept into $1 billion industry. And a lot of amazing engineering went along the way. And so there's all kinds of cool stuff that goes along with working in the technology fields. And then you expand that out to systems and systems and systems, and it gets even more crazy. But part of the being competent, let's say you're really good at reliability modeling. You can model with block diagrams or with fault trees or with Petri nets or Markov models or all kinds of different modeling things of systems. Knowing about the 15 different styles of models and fitting the right modeling for the particular circumstance is what I'm talking about as being competent. So, but you may have a great depth of expertise, but if you're the reliability person in the group and somebody says, hey, could you run a halt test on this new prototype, but you only do modeling, well, you're not in a position then to add a lot of value for that particular request or circumstance. So I think hopefully I made that point there. At an individual level, if you run a really good accelerated test and it makes a difference and the customer loves it and they buy your product, that's adding value. There's no doubt about it. But you probably weren't working with a big team or any team at all to actually set up, run, and analyze that accelerated test. I mean, you could be just assigned, hey, can you run this test? And you go off and do it. Being competent is enabling the rest of your team to succeed. So it may be recognizing, there's a trade-off here in this mechanical engineering solution to the problem. Bringing in reliability considerations to that improves the overall design, not just the reliability part. Maybe easier to manufacture, which reduces variability in its final performance. It improves scrap rate, it improves the durability of the design, it improves the team's success. And so that basic idea of being competent is that you're not a one-tool person, you're not doing it all yourself, is that you are working with other people. And all of those soft skills that many of you have heard me talk about are more and more important. You may not be the facilitator, but you can add value to a team, right? And in some cases, you may be the facilitator. And how do you work with others so that they get the best out of that conversation or process as possible? If the team is successful, it's usually because the team members are supporting each other to be successful. And recognizing that shift from just running a set of tools or running a particular method is a criteria of being competent in what we do. And so it's one more thing to think about here. Let's see. And at some point in being good at what you do and being competent in what you do, this guy, Peter, is going to walk in and say, hey, we want to promote you. We want to make you a manager, or we want to make you, something else. So let's say you're a reliability engineer, you've been working with this company for 4 or 5 years. Where do you consider yourself better serving the organization? And there's no right answer to this question. And I think each of us needs to do that. But are managers the only leaders, or are leaders anywhere in the organization? And hopefully that's an easy question. I think I'm going to steal your definition there, Kim. That's excellent. Leader equals multiplier. Typically can be informal or anywhere. Yeah, there's one of the things we can do in reliability engineering is be a leader, even early on in our careers, even as we become competent. It's when other people look to you to answer questions or provide information or provide guidance, is saying, you know, this is a brand new widget here. We need to understand how it fails. And here's why. Now, that may not be a management decision. That may be a leadership role that you take on. Now, managers, if you've got a bunch of leaders in your organization and you treat them well so that they are effective leaders, that may be a multiplier of a multiplier. So it really depends on your style, what you want to do, what you see your role is. But the difference between a reliability engineer and a reliability manager is one gets to figure out the budgeting, and the other ones actually help people make decisions, or both can. But I'm a little bit biased on this one. I think part of our role, whether we're a manager or not, is to be a leader. And as we become competent and we are recognized as an expert in a handful of areas and well-versed in the organization's constraints and priorities and how things get done, that leadership then takes us into a new realm. And so that's the next step, is being great. Now, this isn't the best of titles by any means, but it's the one that I think is what led to the title. Being great means that you're not only effective with the team that you're supporting, or multiple teams. Many reliability engineers get to work with 2 or 3 development teams, and depending on your industry. But you also then say, you know, at the organization level, we need to look at our bonus structure, or we need to focus in on our warranty policies, or at the corporate level, let's manage, you know, customers' expectations, or whatever it is. And a reliability engineer has the ability to influence at the corporate level. There's no doubt in my mind that, and I've seen it many times. The thing is that it's the value that you create, right? If you are able to come up with a idea or a set of information and cause the organization to make changes to the system or the way we do business that cuts, say, the ongoing failure rate in half, that shows up in your financial results. That actually makes a difference that shows up on the spreadsheets that the finance guys are using all the time, right? When you're called into a meeting and it's a $1 billion decision, do we build this new facility or not? And it's hinged on what's the failure rate, and you're the one that provides that information. Now you're adding value, providing information at the organizational level. That's what I'm talking about. Is part of the things that we work on have a very broad scope. But many of you mentioned it earlier, is it's not that you just do exceptional work, it's that your work is recognized and that you get asked these questions that are because they know that you can provide information that will help them decide to build this new facility or not. And it's a big decision, big being material to the organization's financial success. Now, here's a hypothetical for you. Let's say you get really recognized and good at being able to cut failure rate product failure rates in half. What happens if you're asked to cut it in half again, and then 6 months later again, and then 6 months later again? So let's say you start with a 10% field failure rate, and they say, hey, we need to fix this. We need to cut it in half. Now, that's not an unusual problem for some products and industries, but how many times can you do that before it just doesn't make sense? One of the examples I run into is in the courses I teach at Maryland. I ask for recommendations for how an organization can improve their reliability performance. And I get 5 recommendations, and each one cuts the failure rate in half. And do you see where the problem is here? Anybody recognize why continuously cutting the failure rate in half leads to a problem? Even has a name. Yeah. Yeah, it'll cost more. I think Kenneth and Maximilian are both on the same idea, diminishing returns. So cutting from 10% to 5%, yeah, it's not trivial, but you might be able to do it, right? Cutting it from 5% to 2.5%, depending on your material set and set of constraints, that's probably feasible, but it's going to cost you more and take some more effort and so on. But I get down to 0.5% and trying to go to 1/4%. I need to start thinking about production lines and vendor reliability and raw material supplies and all kinds of stuff that it just may not be feasible from a financial point of view to even go after it. Yet, a good reliability engineer, a competent reliability engineer, James, the 80-20 rule, yeah. John, you must work in either the auto industry or the military. Is getting there with the losing your aftermarket sales. But the idea is that just cutting failure rate is not what makes you great, right? It's the ability to add value when it's not just cutting the failure rate. You may be reducing the risk of shipping late. You may be change a fundamental process in the organization so that products launch on time 95% of the time versus 60% of the time. Just think of how much money that saves an organization when they can predictably launch when they expect to launch and then move their teams on to the next programs and on the next activities. But value comes from all kinds of different places, not just failure rate. And so shifting from competent to great is recognizing those various sources of value of what's important to an organization. Now, if you're in a large organization, and I've heard this inside a number of organizations, is that we are a publicly traded company. We need to have our quarterly financials need to be predictable. And I never really understood what that meant until we started looking at what difference does that make? And it affects not your customer's point of view, but your financial, the shareholders of your company. And that changes the market price of your stocks. So if you're not predictable, you'll be priced lower. Now, I never really understood why that mattered much. They own the company, or whatever, but it does with fundraising, with getting additional capital to fund projects, and it affects levels at an MBA level that I have only touched on and don't fully understand. But I know it makes a huge difference because there's so much focus on it and so much attention paid to it at the high levels of these major corporations. The bottom line is that when you can create a program or set up systems that help the financials become consistent, that makes a difference at a very high level in an organization. It's easy enough to go find a financial person and ask them, what causes the uncertainty? And in more than one organization, it was, well, we launched 10 products last year or last quarter, and 5 of them had lower than expected failure rates and warranty claims, and 5 of them had greater than and higher costs to the warranty extremes. And sometimes that balances out and doesn't matter, but sometimes we're swayed to too high of warranty costs and too high or too low of warranty costs. And those go directly against the profit, which makes predicting profitability difficult when we have this major contributor that varies so much. And so if you can create a system that helps development teams create a product that meets their reliability objectives, it actually improves the predictability of you in the stock market. Let's see, questions here, but it's one that it takes a while to sink in, I think. But as you're working on warranty policies, you're working on setting up and working with repair centers across your organization so that you actually get first time right repairs. If you're changing the senior management's product bonus structure so that it includes warranty costs, if you're, adding value at the organizational level, that's one aspect, I think, of being a great reliability engineer. Excuse me, catch in my throat. But I think equally or even more important, how great would it be, no pun intended, is that if the 4 or 5 people that you're working with and encouraging to become better reliability engineers or better engineering managers or better whatever they are, and they make these organizational level impacts, right? You might not ever get credit for that, yet you were instrumental in making it happen or causing it to happen. If you can help somebody understand that they actually were successful and they can take credit for it honestly, that builds their confidence. That allows them to move forward and take on more challenges and confidently take on more challenges and bigger challenges. So part of being great is not yourself by any means whatsoever. I think being great, and for many people, it's much more satisfactory, is that you actually set up systems and processes or education or awareness or techniques that allow other people to excel, to do really, really amazing, great work. And I think that's a hallmark of a great reliability engineer, is how do you enable others to be really good at what they do, right? And given the way some organizations work, you may or may not ever be recognized in any formal way for it. Yet for those that are motivated by knowing that they've done a good job or contributed in a meaningful way, that's, for many people, that's sufficient. It's great. But I think that's another aspect of it, is not only are you working at higher scope problems or larger scale of issues and complexity that you're working with in the reliability field, yet you're also extending that out to to our peers and enabling them to do really, really great stuff too. And then finally, this is probably more of a pitch to get people to contribute to articles and webinars and workshops and so on through Accendo, is share what you know. Part of being a great reliability engineer is that you've gained a lot of experience and that you've learned things both the hard way and you've learned things in interesting, fascinating ways. And you've got great stories, you've got great insights, you've got great ways you got great knowledge, right, in the field. And so the idea is that by teaching or presenting or doing an article series or contributing a podcast or a webinar or something like that, and doing it on an ongoing basis, not only inside your company, but outside, let's now influence the industry. And the idea is that by the mentoring, coaching, and the sharing of your knowledge in general, is it takes people through this progression from just getting started to being competent much faster. And just think of how much value it is to the industry when now we have instead of 50 of us struggling through learning what's the differences between ALT and HALT, our combined ability to share our information allows that progression to go much quicker, that it becomes more inherent knowledge rather than struggle to learn knowledge. It becomes clear in a number of different ways. And that's just one simple example, but when do you use which one of these, and how do you adjust what your accelerated testing for your particular conditions? If you can help other people make those decisions and understand them, not just make the decision for them, but to understand how to make those decisions themselves. Instead of 50 engineers struggling to learn the ropes, so to speak, we've got 50 engineers that are competent and moving forward to where they're going to start sharing what they know with the next group of folks that are just getting started. I think the ripple effect of that is well beyond even cutting your failure rate in half within your organization. And so part of being great is the scope of what you're working on and the types of problems you're being expected to solve. But also is that you're able to enable others to do it. And then in a broader scale is you share what you know, and it makes a difference. That's the cool part. It might be great to share. I saw a presentation years ago. It was about a block diagram where they had a nuance that they were trying to make it so that it was more like a state space type modeling system. So it would, instead of it worked or didn't work, it would deal with these different states. It was in a degraded mode or not degraded mode. So they made a new block to put it in there. And somebody asked them, so why don't you just use the Markov modeling techniques or FeatureNets or one of these other systems that does this pretty seamlessly? And the question was, well, we just wanted to see if we could. Well, have you used it in any real application? Well, no, this is just theoretical. All right, okay. So it's kind of like, so what? But the idea of actually enabling others to get through the basics, to get into being really good at what they do, to support people building expertise, to me, that's the hallmark. That's what enables us to assist our peers to become competent and beyond. So here's a few thoughts for you. Let's see, I think I've got one more person. Oh, can one person shape the culture of an organization? It's kind of a, if you've seen some of my other webinars, you know that this is possible. But part of it is the persistence, part of it is competence, part of it is the ability to have influence and to alter the way people go about making decisions and the behaviors of what they do in the development of a product, for example. There's a culture around reliability within an organization. And the easiest example is, does your organization celebrate failures so that we can understand why it failed and do something about it and learn from it? Or do people just not talk about product failures? And we just kind of, if we don't talk about it, they don't really occur. Those are different hallmarks of different cultures around reliability. Now, one may be not better than the other. I have my own opinion in that. But the idea is that the ability for a reliability engineer, even early on in just getting started, to say, there's something we can learn from this, and let's dig into it a bit and understand it and recognize that, if you use this material, it will soften at 125 C, which is our internal operating temperature. So let's look at a different material. That simple observation is not only solving that particular problem, but it also demonstrates a way to approach problems, is that this failure is an opportunity and a way for us to learn and influence or improve our product's reliability. And by demonstrating that, even on simple early on problems, is a way to alter the way people think about, not just you, but the people that witness this, the way they think about failures. And that starts to change the culture. And that's just one example. So coming up on the end here, I think I've got one more slide. And let me check to see if there's any more chat or windows here. And Carl's got a link off to bringing value to a team, sales coaching. That might be interesting. Carl, a lot of the stuff you bring on is usually interesting. So I enjoy the links and insights you bring in. Oops, let's see, there's a couple more here. You know, Carl, your comment here, sharing knowledge sounds like a good way for older, experienced employees to act as mentors. You know, you don't have to be old. Like this slide now is that, yeah, it takes time. You need to build the experience, but it can be, if we work together and if we share our trials and tribulations and ways we solve problems, both hard skills, like what types of failure mechanisms are occurring, and soft skills, how do you influence a team? We can shorten that timeline. I think we can act as mentors, even as a, you know, been in the industry for 5 years. That can happen. And so I don't think it's all the way out there. And one of the things, I mean, early on, one of the earliest product development teams I was on, I was the only single contributor, only engineer on the table. The rest were managers. And other than the project manager. And I was like, why am I here? Why am I at this table? It's just because you're the only other person that has the span of the scope in your job title that's similar to mine. You have to deal with software, electrical, mechanical, marketing, finance, everything else. That's what reliability people have to do to be effective. You know, I didn't realize that at the time. I thought I was there just, you know, which test do I need to run? But the more I thought about it, the more true that was. And so helping other people as they're getting started recognize the scope and impact potential that we have shortens that timeline. So some of it is just being aware that you can actually make a difference, even early in your career in the reliability role, because of what we do. So those are a couple aspects. Oh, little admin stuff on the comments area there, no problem. All right, well, I think that's our just cross the threshold for the time. Every now and then we do run late, but I'll stay on the line if there's any other questions or comments or stuff. But thanks to everybody for attending, and we'll see. And of course, I have no idea what the event is for next year or next month, that we hopefully advertise it well enough that you can find it. And we'll go from there. Everybody, lots of thanks there. You're very welcome. Yeah. All right. Thank you all. Appreciate it. My trouble is the way my screen works here is I got the presentation up and I can't see anything else. I should actually make a note someday, my own process improvement, although I've been saying this for like 10 years, but I will make one last thought here, is that as you're all signing off, heading off to whatever your day's tasks and challenges are, is if you've got an idea or a topic or a concept you'd like to present, let me know. I'd love to get you to do a webinar in my place. I'd much appreciate that. And one way for you to share your knowledge. And so just get in touch and we'll make that happen. So thanks again, everybody. And as always, enjoyed your input and feedback and insights. And we'll see you again in a couple of weeks when Chris Jackson's got a presentation. And then I'll be back, as far as I know right now, in a month. But we'll see y'all later. Have a great rest of your Tuesday. And go have fun. Go make a difference.